All right, so thank you everyone for joining us tonight. I know we have more people joining us as we speak. You can see pinned in our view our keynote speaker for tonight, Debra Ceravolo from BC. We'll introduce her shortly. We also have our center president, Paul Simard, and we have our vice president, Maury Portnoy. My name is Kareem Jaffer. I'm the public events coordinator here at the RASC Montreal Center. And so before we jump in, I just wanted to tell you a little bit about the center. And we're also going to be joined shortly by our honorary president, David Levy, who many of you know, a world famous comet hunter who is down in the States now in Arizona, but joins us regularly at our Zoom clubhouses that we've started since Zoom began. So as you join us, please do say hi in the chat. Let us know where you're joining from. We try to start all of our events with a land and sky acknowledgement. And specifically, we recognize that we are on unceded Indigenous lands, and we all are here in Canada and all the different parts of Canada. And we do a land acknowledgement in a lot of our local institutions, the academic as well as some of the public institutions. But one of the big things that we recognize as the RASC Montreal Center is we share the sky with the Indigenous peoples. We just passed the vernal equinox, which is an important date for cultures all over the world, a time of rebirth, a time of reinvention and reverence to the act of life. And when we look at the moon cycles, every full moon has a meaning to the Indigenous cultures. And the current full moon that we have tomorrow is the sugar moon. And it's been seen as such in most of the local peoples from the Mohawk and the Algonquin and the Cree, the Ojibwe, and even the European settlers refer to it as the sugar moon because it is the time of sugaring of maple trees. And so I've got a few friends with maple trees in their farms, and they've been posting pictures of their wonderful, slightly smaller than usual harvest this year, but I look forward to tasting some when COVID is done. Our RASC Montreal Center is part of 29 centers across the country. We're the largest, most active amateur astronomy group in Canada. The Montreal Center has been around for over 100 years, and we have 160 plus members of all ages. And we provide events during COVID times virtually, but we've been doing these since the start of COVID. We actually switched over to Zoom clubhouses within a week of the COVID pandemic beginning. So every Wednesday and Saturday at 8 o'clock, other than when we have public presentations, we have members' presentations to begin an evening, or we just have an evening of discussion and sharing some of your passion. So we just had a presentation earlier this week on focusing and collimating telescopes. Our coming Wednesday presentation is going to be on the April night sky, so people can plan out observing sessions now that our curfew here in Montreal has extended just a little bit. And then in mid-April, our treasurer from our board, Ben Chutang, is going to be talking about choosing the right camera for astrophotography. And these are members' clubhouses, but we always invite guests to join us. Just drop us a message or come join us from our calendar, and you can meet the RASC members and get to know us a little bit and what we do and why we have a passion for the night sky. In-person events are unfortunately still on hiatus, but we've kept our monthly events going. So tonight we have our astrophotography talk that we'll talk about shortly, and Earth Hour begins immediately after the talk. On April 24th, we have a scientific presentation on small satellites, big stars, and I'll talk to you about that shortly. And we're starting to plan International Astronomy Day for May. So you can visit us on our calendar or our Facebook page to learn more about us and our events. Our April event, we're going to be sending this out in the coming, probably in about a week, we'll send out the invitation. But you can register at any point at bit.ly/bright2021. And it's a scientific talk on studying massive bright stars using the Bright constellation. The Bright constellation is a set of nanosatellites in orbit, and Dr. Anthony Moffat from the University of Montreal is one of the researchers who accesses the data from Bright to learn more about the way these stars function. Now for tonight's talk, to introduce our speaker, I'm going to call on Maury Portnoy, but before I do, I just want to check and see if David has joined us. Our center honorary president, David Levy, joins us every Saturday to chat with us a little bit about his adventures. I don't see him at the moment, so I'm going to turn it over to Maury. And Maury, if you can introduce our speaker for tonight.
Okay, I unmuted myself. I thought you were going to do that. Okay, I just want to welcome everybody, our members and our guests, and anybody out there who celebrates Passover. I wish you all a good Pesach. And well, hopefully next year we'll be with our families. Normally, this is an evening that, as a center, we're normally at Westmount celebrating Earth Hour. But tonight, because of COVID and the power of Zoom, we are out in BC, at least digitally. We have a great guest who I initially found her or stumbled upon in Facebook, seeing one of her photos, and I was just blown away. Not only her photos, but her words, her passion came through. And that really put Debra sort of in a unique position. I just knew we had to have her share her passion for the night sky. Debra is a RASC member of the Okanagan Center in BC and lives, as she said, in an astronomical utopia or heaven, or living on a mountaintop, literally, with beautiful skies, beautiful views, and above all, an amazing observatory and telescope that her husband designed and built. So tonight, Debra is going to show us her images that she takes, her way she uses it, her philosophy of astrophotography, and just her passion. And at the end of this talk, there's a test. Only one question. You have to determine who was the real star of the video. So without further ado, I invite Debra to share her images. Thank you.
Thank you, Maury. So we are going to share a video that Debra has already prepared for us because of the possibility of some bandwidth issues since she's joining us from rural BC. Once the video is done, we're going to open it up for questions and discussion. Okay, so just going to mute everyone, then I'll let Paul share the video.
See the video?
Yep, go ahead and press play.
Oh, I'm Debra Ceravolo, and I have been doing astrophotography for more than 2 decades now. It's my passion. The very first astrophoto I have ever taken was in 1997 of Comet Hale-Bopp using a film camera. I have since progressed in the hobby, and I'm still learning a lot. This is not a tutorial on how to take astrophotos or how to process them. It's more of an overview of what can be achieved using different equipment. Everything from a cell phone to a tripod and camera, all the way up to a high-end deep sky imaging train. And every astrophoto is an adventure and has a story to tell. Not of the how, where, and when, but the what. What's going on in the image? What's the science behind it? And what can we learn from it? So let's get started. So let's start off with a short video showing how to find the Horsehead Nebula inside the Orion constellation. Here I used 4 different imaging setups, all the way from a camera and tripod with a 20mm lens, and a camera and tripod with a 50mm lens, and then the deep sky imaging. Here we're going into the Horsehead Nebula, and the deep sky imaging setup I use, it's about a 1400mm focal length, and from there we go all the way into the Horsehead itself, 2700mm focal length deep sky setup. I'm going to go over the images from the video in more depth and then move on to talking about equipment, starting with the basics. This is a scene from my backyard on Anarchist Mountain in southern BC, and the town on the right is Osoyoos, BC, and the town on the left is Oroville, Washington. We're basically right on the Canada-US border. It's a classic winter scene with the constellations Orion, Taurus, with the Pleiades, and Sirius. Here's Orion with the 3 belt stars and the sword. And you saw that the Horsehead is right about there. And this is Sirius, the brightest star in the sky. And then this way is Taurus, the bull, this V-shaped face with the Aldebaran, the bright red star as his eye. And the tassel on the bull's tail is the Pleiades star cluster, also known as the Seven Sisters. So this is a classic winter scene that I wanted to get with the full moon. The foreground is lit up by the full moon. I did this intentionally because I wanted the mountains and snow to show up nicely. If there was no moon, the foreground would be very dark and noisy. So the sky is pretty affected by the moon, and only the constellations show up, and that was my intention. The First image, the wide field scene, was taken with a Canon 6D and a 20mm lens. It's the big wide field here. And this was on a simple tripod and was fairly fast exposure time because of the brightness. The next shot was using a modified Canon RA with a 50mm lens on a tracking mount to get longer exposures in order to bring up all the nebulosity that's surrounding Orion. A modified camera has had some filters removed to allow the red hydrogen alpha in, all this good nebulosity there. I had to expose the image longer, and it took several shots, and then I stacked them together. This required a tracking mount rather than a simple tripod. And here we can start to see a little bit of the Horsehead nebulosity all around it here underneath the first star of the belt of Orion. And there's Betelgeuse and Rigel. Now these stars they're diffused to bring up the constellation so you can see it better. And also it spreads out the light of the color of the stars and makes that a little bit more obvious as well. This is the jump from a DSLR camera with a 20mm lens to a 12-inch telescope and a cooled CCD camera with a filter wheel. The focal length was about 1500 millimeters zoomed into the famous Horsehead Nebula. Here you can really see the change in the resolution. Processing at this image scale is much more complicated, as there are hundreds of images that have to be calibrated, combined, color balanced, and much more processing. Learning how to use the equipment takes effort, but learning how to process the images is critical. Otherwise, you'll end up with a huge hard drive of raw data that never sees the light of day, so to speak. So this is the Flame Nebula and the Horsehead. Let's go back to the previous image. So here's the little blip of the Horsehead you can see there in the red nebulosity behind it. And there's the Horsehead there. This is the size difference when you go from a 1500 millimeter focal length to a 2700 millimeter focal length. It's quite a big difference in field of view and image scale. So here's the Horsehead at 2700 millimeter focal length. I plan to do a lot more imaging on this object to get a lot more data that I can add to it to really bring up all this dust all around, which I'm not quite there yet. It's still a work in progress. But the Horsehead it's a dark nebula. It's made up of dust rather than gases, and it is blocking the light from behind it. And this is how we see this shape. It looks like a horse. So let's start with the simplest form of astrophotography, and that is the cell phone. And I realize there are a lot of cell phones now that can do a pretty decent job of capturing the sky at night, especially Milky Way shots and that sort of thing. But one must realize that it probably needs a tripod to steady it. And also the software in these phones are doing a lot of processing internally without you knowing exactly what it's doing. But it makes astrophotography accessible to a lot more people, as everybody has a cell phone. I think eventually it will lead to wanting to get more out of an image. For this photo, I held my iPhone 7 and up to the eyepiece of a telescope, or in this case, a solar telescope. It was a 90mm Coronado, and I captured some solar prominences. That's the sun's magnetic field shapes the solar prominences and sometimes creates loops like this. You can do this same technique with the moon or pretty much anything in an eyepiece. It's just you got to hold it up to the eyepiece and hold it nice and steady, and who knows what you'll get. It should be really fun. There are many challenges on every level of astrophotography, and one of the challenges I have is my cat. He loves to rub up against the legs of a tripod when I'm outside with it, and I have to guard it. But this is a very simple setup, and you can do a lot with just the tripod and a camera. So using that setup I just showed you, I photographed the planetary conjunction of Jupiter and Saturn overlooking Oroville, Washington. You can see the Christmas lights reflecting off the lake. This was actually the day after the closest pairing, as we had clouds during that event, but it was still close the next night. And there were still some clouds around, but that actually added to the photo because the thin clouds diffused the planets and made them glow even more. It's a single shot using my Canon 6D and a 70mm lens. I put the ISO up to 1600, and it was a 10-second exposure. These two planets appear to be together in the sky, but in reality, Saturn is twice as far away from us as Jupiter. I love wide field astrophotography as it gives us a connection to the sky. The foreground is familiar and gives us context. Wide field astrophotography is also very forgiving, meaning you don't have to be so precise as we do when it comes to deep sky imaging. This is the same setup but using a 14mm lens, which is a bit wider than the 20mm that I used before. It's a quick 6-second exposure at f4. This winter scene with Orion and some of the cirrus clouds overhead causing the halo around almost full moon. There's an old saying, a ring around the moon means rain is coming soon. The high cirrus clouds usually precedes a storm or some kind of weather. Aurora, or northern lights. Again, using a camera on a tripod, I used my 20mm lens here. This is only an 8-second exposure, and the aperture was opened up all the way. I think it was f1.4. For most night photography, you should open the aperture all the way. Sometimes, though, if the lens is very wide, like a 14mm, you might want to stop it down a little to prevent vignetting. This scene is from my backyard on Anarchist Mountain in southern BC, and most of the photos I will show you are captured from my home. I remember the night I took this photo. It's very rare for us to see an aurora at all here, so it was quite exciting to see that. I also remember having to guard the tripod from the cat. I increased the ISO so I could keep the exposure short. When it comes to aurora, the shorter the better, as it shows more structure and streaks. Longer exposures blur the aurora because they are moving quite fast. The northern lights are actually the result of collisions between gas particles in the Earth's atmosphere and charged particles released from the sun. The colors are due to the type of gas particles that are colliding. The most common color, the pale yellowish green, is produced by oxygen molecules located about 60 miles above the Earth. The red aurora are produced by high altitude oxygen at heights of up to 200 miles. Nitrogen produces blue or purplish red aurora. So this is not an aurora, but a phenomenon called Steve. I thought it was an aurora, but some of my more knowledgeable friends told me otherwise. And in fact, it is Steve. I'm not sure what exactly is happening with this phenomena, but it often happens around the same time as an aurora, but south of the auroral band. Something to do with electrons being stripped in the ionosphere and heating up. The picket fence streaks look to me like a lineup of comets. One thing I've learned is always have a camera with fresh batteries on a tripod, ready to go for whatever comes along. Otherwise, I would never have captured this Steve shot. Taken with a 20mm lens, f1.4, 20-second exposure. So still using the same setup with a simple tripod and a camera and nothing else. I caught these Noctilucent Clouds last summer. They are very seasonal things. They only happen in the summertime. And so it's another example of local phenomena where wide field astrophotography is best utilized. I used a Canon 6D and a 135mm lens. These clouds are special and they're not local. The Noctilucent Cloud actually needs night shining. They consist of ice crystals way up in the upper atmosphere of Earth, about 250,000 feet, right at the edge of space. They're actually seeded by meteor dust, and they shine a beautiful blue-green at night, and usually seen toward the north. This was the summer of 2020, and I noticed them when I was closing up my observatory one early morning. I've never seen these clouds before this photo, and then they showed up again a few weeks later. More Noctilucent Clouds 2 weeks later. This shot was a shorter exposure than the last one with 1/2 second exposure. So the clouds were not smeared or blurred. Like aurora, they are moving quite fast, so shorter exposures are better at defining the structure and not blurring it. And I used a 70mm lens here, but the ISO was much higher at 2500. These are really quite beautiful, beautiful things to see. And Comet Neowise made the summer of 2020 quite a memorable one. I was out there photographing it every morning or night when it was visible, almost the whole month of July. This was taken on July 20th, and this shot was a 36-second exposure at f6. ISO is 2500. Captured with my Canon 6D and a 50mm lens. You can see the bowl of the Big Dipper. Here, let me get my pointer. This is the bowl of the Big Dipper right there. So sometimes light pollution and clouds can add to a scene. We all usually want perfectly clear skies, but sometimes we can take advantage of what we're giving. This was a great comet, very photogenic. It moved a lot and changed its appearance throughout the whole apparition. So stepping things up a bit, it's fun to do time lapses in star trail photography. Attached to the camera here is an intervalometer that can be programmed to take continuous photos with a few second intervals between them. The tripod is not tracking the sky, so each photo will show movement in time. So there's the intervalometer there. If you have the intervalometer set to take many photos for an hour or more while the sky is moving, the result is interesting. You end up with hundreds of photos that can be stacked together that shows the motion of the sky. If you point the camera toward the north, you'll get something like this. So the North Star here is directly above the Earth's axis of rotation, so all the stars rotate around it in a circle. This photo reminds me of a time when I had some espresso coffee after dinner with my husband at a restaurant one night. And I couldn't sleep at all, and since it was very clear out, I grabbed my tripod and camera and intervalometer, and my husband and I hiked through deep snow on a neighbor's property that had this 12-foot Inukshuk. I put the tripod really close to the ground, as close as I could get it, and I was literally lying down in the snow to focus. This photo is actually a composite. I first focused on the Inukshuk while painting it with a flashlight and took a single shot of that. Then without moving or bumping anything, I focused on the stars. And then I set the intervalometer to take consecutive shots of 20 seconds each and went back to bed. It continued to take photos as long as the battery lasted. The reason for the composite is the Inukshuk was very dark when the exposure was concentrating on the sky. I like how the Inukshuk, which is a symbol of the north, is looking up at the North Star and the spinning world. The stars are ever so slightly blurred to make the colors come up a little bit more too. And here again, this is 20-second exposures, one after the other with 2-second intervals for about 3 hours. It really gives us the impression of movement, and I think it gives us that connection to the sky and our relationship to Earth as well. It's quite dizzying. When doing star trails, it's important not to move or bump the tripod, so the foreground is the same and no interruption in the sequence. So don't let the cat out. Here's another thing you can do using an intervalometer. Instead of combining a group of longer exposures into a star trail photo, I've taken shorter exposures to keep the stars sharp for several hours and made a time-lapse video. I used LR Timelapse, an Adobe product, and was able to create this winter scene. Here is bright Venus. First I'll run it. Here is bright Venus, and above it is the Pleiades star cluster. You can see lots of satellites and even Starlink. And Taurus, the bull, is here. Here comes Orion, the constellation. And you can see all kinds of cars moving along here. And here, this is a dome, a light dome coming from Vancouver, which is about 5 hours away. And this is a light dome coming from Seattle, Washington. So if I want to do longer exposures because I want more detail and resolution, I will need a tracking mount like this. This is an old Super Polaris mount. I don't think they make them anymore, but it still works really well, especially for wide field photography. It has a motor that moves the camera or telescope, matching the rotation of the Earth. These mounts are also nice for just observing with a telescope because you don't have to keep adjusting the object in the eyepiece. Doing tracked photos opens up a whole new level of depth and detail. The long exposures allow more light in without star trailing and brings out nebulosity. So this was taken with the Canon modified RA DSLR with a 20mm wide angled lens on vertical, and it was on the Super Polaris tracking mount. I exposed it for 4 minutes, and without the tracking mount it would have been quite trailed. So memories of this one was a very humid night, unusual for southern BC, and the lens frosted over, creating the halos around the stars. This made the colors of the stars spread out and become a lot more obvious. When you're tracking on the sky, the foreground will blur as it did here, but I like the effect. It's not a composite, but a single shot image. Sometimes the clouds descend below us on the mountain and it covers the valley, and when the sky is clear, it's magical. A summertime shot. This is a 2-minute exposure using a modified Canon RA on a tracking mount. The summer Milky Way shows up quite well, along with, let me get my pointer, this is Jupiter and this is Saturn, which many months later they come together. This is my observatory called Anarchist Mountain Observatory. At the time, I was imaging Comet Neowise. The Milky Way as seen from the southern hemisphere here. We can't see this at all in the north. This is a 2-minute exposure on a tracking mount. I took this single shot on a trip to Chile. Amazing place. I highly recommend it. These two objects are called the Large and Small Magellanic Clouds. They are not actually clouds, but satellite galaxies of the Milky Way. They are gravitationally bound to our own Milky Way. Okay, this getting into a little bit longer focal lengths. This is my 70 to 200 millimeter lens, and it came in handy when I was photographing Comet Neowise. I was able to frame it quite well, somewhere in between something like 135 millimeter and there. It's nice thing about having a range of focal lengths is you can frame your subject in any way that it needs. And Comet Neowise. So using that setup with the Super Polaris mount, the lens was set at 150 millimeters, and I took 10 photos of 70 seconds each. And then I stacked them together into one photo in Photoshop with a total exposure time of around 11 minutes. If I did just one 11-minute exposure, it would end up being oversaturated and noisier and maybe even trailed if my Polaris alignment was not perfect. So this was Comet Neowise taken on July 14th, 2020. So this is the Venus-Pleiades conjunction I took last April 3rd, 2020. I wasn't tracking here because the exposure was very, very fast at only 1 second. The sky was quite bright, and I used a 200 millimeter lens on the Canon DSLR, and of course there were a few clouds there, but I thought the clouds actually added to the photo. So stars are always pinpoints of light, but as we get more zoomed in or using longer focal lengths, the atmosphere has a greater effect on the bloating of the stars, and I'll show how that wreaks havoc with deep sky imaging. So this shot of the moon set, I used 200 millimeter lens. It shows more detail on the moon, and the moon looks bigger here than it would if I used a wide field lens like a 20 millimeter or 14 millimeter. The moon would look tiny. So in order to get the moon to look bigger, you've got to go for longer focal lengths. And this is a 4-inch refracting telescope that I have with my Canon DSLR on the back. It's nice to use the telescope to get even better detail, especially for the moon. The longer the focal length, the bigger the moon. The focal length of this telescope is 770 millimeters. So I'm going from a 200 millimeter lens to a 770 millimeter lens. Still, the exposures have to be short because the more zoomed in you are, the faster everything moves through the field, unless it's on a tracking mount. And at this focal length, the tracking has to be very precise. It's no longer forgiving here. So using that setup, I took this photo of the moon setting while the sun was rising in the opposite direction, turning the mountain peaks pink. I didn't need a tracking mount here because the sky was quite bright and it was a short exposure of 1/500th of a second. The atmosphere was extremely steady that morning and it did not distort the moon. At some point, we want more aperture. We get a taste of seeing clearer with more detail and we want more. So this telescope is 12 inches. It's 1500 millimeter focal length with a DSLR on the back. And I was photographing a lunar eclipse from my observatory. I wanted the moon to be bigger still, and the camera was modified to allow more red light in. Peter took this shot of me in our observatory a couple of years ago on January 21st, 2019. Orion is standing on my shoulder. And here's the moon shot at full eclipse. I took many photos over a 4-hour period, and I was going to make a time-lapse movie, but I made a montage instead. So I took many more photos than this over a 4-hour period and was freezing at the end of it, but it's a passion. Now, here is where things get a lot trickier. This is the deep sky imaging train set up with a 12-inch astrograph designed and built by my husband Peter Ceravolo. It's a Ceravolo 300 at f4.9, so it's about a 1500 millimeter focal length. It's mounted on a Paramount ME2. The camera is an S-Big CCD mono camera with a filter wheel. And on top here is a Pinwheel Eagle 3 Pro computer that I can download all the images there, and it also powers all the accessories, and it keeps all the cables under control. To make all this work right, it's a whole different ball game and a test of one's patience. I don't recommend anybody getting into this kind of astrophotography before you've learned a lot about astrophotography in general using simpler setups. Not only do you have to take separate images with different filters, you have to take flat field images for each of the filters and darks and bias frames to null out any thermal or electronic noise and dust on the filters and mirrors. Then you have to calibrate all the frames and align and combine them even before you get going on the fine processing. Phew! Like I said, it's a lot of work, but it's a passion. As I said earlier, wide field photography is forgiving because we don't really see the effects of imperfect polar alignment or slight movement of the sky or atmospheric distortions. But when you get into deep sky astrophotography, these effects have a great impact. The amount of atmospheric turbulence, which we call seeing, can wreak havoc on the images. Our atmosphere has water vapors and gases and particles moving around, and the jet stream plays a big part in how the seeing is. The more turbulent, the more the stars and objects bloat and bounce around on the camera chip. There are some nights that I just give up because of the distortions, and it would contaminate my good data. One way to see if it's going to be a good night of imaging is to look up and see if the stars are twinkling a lot. Twinkling stars are pretty, but not good for imaging. This raw video of Saturn shows how bad seeing can distort objects. So now we're able to capture much detail and nebulosity. The Pleiades, or the Seven Sisters. This is a 1-degree field of view using the set I just showed with a 12-inch telescope. It's a total of 3 hours of RGB data combined and processed in PixInsight. I like PixInsight, but sometimes I use Photoshop and whatever else that seems appropriate for the subject. Basically, you use whatever is at your disposal, and there are lots of free image processing software out there as well. But the main thing is, it takes time to become proficient at any of them. But there are lots and lots of great tutorials on the web. So this is the Andromeda Galaxy using that 1500 millimeter setup. It can be seen with the unaided eye in dark skies and easily seen in small telescopes. At 2.5 million light years away, Andromeda is a little larger than our own galaxy, and it has about 1 trillion stars. It is the most distant thing visible to the unaided eye. In about 4.5 billion years, about the time when our sun begins to die, this galaxy will merge with ours. In fact, very recent news states that there is evidence that the merging has already begun. I want to point out the 2 other galaxies next to Andromeda, and I think it's M32 and M110. And these are interacting with Andromeda, kind of like the Magellanic Clouds that are interacting with the Milky Way galaxy. So this image of Andromeda is closer at 2700 millimeters. It's the same telescope, but you can swap out the corrector cells and make it from a 1500 millimeter setup to a 2700 millimeter. So we're a little bit closer in here. Just wanted to mention here in the Andromeda Galaxy, pointed out by the arrow, right there between the arrow and my pointer is a variable star. It's the most important star in the history of cosmology, believe it or not, this tiny little thing. This variable star, it changes its brightness regularly. So Edwin Hubble in the 1920s used it to determine its distance, which put it far outside our own galaxy. But before that, Andromeda was thought to be a nebula inside our own galaxy. So at that time, the universe became a much bigger place after Hubble's discovery. So here's the latest setup I have now. This is the Ceravolo 300, the telescope that Peter made, and it's at 2700 millimeter focal length. Here I'm swapping out the camera that's under my chin there. It's a very small pixel Illuma, the S-Big Illuma 694. I love this camera. It's got great resolution. The size of the field is not 1 degree anymore. Now it's about 12 arc minutes, so we're getting a lot closer in at higher resolution. But things get really touchy at this level. You're imaging such a small piece of the sky. Any movement or vibration, tracking errors, seeing can badly affect the image. In fact, I often throw out almost half the images I take because of stars trailed slightly or not perfectly round, doing the seeing or guiding, tracking errors. Everything has to be aligned perfectly. I switched out all my gear here because I wanted to get some close-ups of Comet Neowise last summer. So this is a very close-in shot of Comet Neowise taken last July 14th, 2020. When the comet's nucleus gets heated by the sun, it creates an atmosphere around it called the coma. Here. You can't really see the nucleus inside because it's buried inside the coma. It's the atmosphere. The bow shocks are the result of the interaction of the solar wind and this coma atmosphere. The green is cyanogen gas, and there's a shadow behind the coma. That's pretty close in, and it's just slightly cropped. I took a lot of photos every night until it became too dim. Here are some of them showing the dynamic changes it went through in a short period of time. So by the time the comet showed up in our skies, it had already gone around the sun and heated up. The solar wind is pushing back the dust and gases away from it, so the tail always points away from the sun. It was such an amazing comet. There are always comets in the sky, but very few that we can see in photographs like this one. And here you can see the dynamic changes of it from this period of time. So galaxies, I love galaxies. This galaxy is one of the brightest in the sky, but it can only be seen from the southern hemisphere. So we caught this one from Chile. The Sculptor Galaxy, and it's undergoing a period of intense star formation. It's a starburst galaxy and about 11 million light years away. As a reference, Andromeda is about 2.5 million light years away. So just a review about galaxies. They are billions of stars that are gravitationally bound together in spirals and other shapes, and there are billions of them in the universe. But up here in the north, this beautiful spiral M101, the Pinwheel Galaxy, is located in the direction of Ursa Major. It's twice the size of our Milky Way, and it's about 20 million light years away, so still within our local group of Virgo cluster. Approximately 10 hours of total data. This is 4 hours of luminance and 2 hours each of red, green, and blue. The Needle Galaxy. These galaxies were all taken using the last setup that I showed. This is an edge-on galaxy with dust lanes. Most galaxies are dusty things. There's a lot of dust all through our own galaxy. This is about 5 hours of data. And this is the Rose Galaxy. This one's pretty cool. We know that the Andromeda Galaxy is 2.5 million light years away, and we know that the Milky Way and the Andromeda Galaxies are part of a local group of galaxies known as the Virgo cluster, which goes out to about 30 million light years. This galaxy, or I should say 2 galaxies, are 300 million light years away. This is the farthest in space that I have imaged so far. These 2 galaxies are interacting and merging. It's called the Rose Galaxy because of its beautiful shape, and it's in a cosmic dance. All the stars that you see here are inside our own galaxy. It's like looking past raindrops on a window pane to something in the distance. The stars are the raindrops, and the galaxies are far beyond. And nebulae. While galaxies are far outside our own galaxy, as Edwin Hubble showed us, nebulae are within our own Milky Way galaxy. They are the most colorful objects to photograph, and getting the color right is really tricky. This is why there are so many variations of colors in images of nebulae everywhere. This is the very center of the Orion Nebula. We're really close in here. Let's go back to the image of Orion constellation to give context. Okay, so below the belt of Orion is the Horsehead, which we know. And down here is the Orion Nebula. This is the most photographed nebula ever. The Orion Nebula is a stellar nursery where brand new stars are forming. And here is a 1-degree field of view of the Orion Nebula, taken with the 1500 millimeter setup. So this is the pointer. This is the nebula itself, and in here is where the trapezium, the brand new baby stars are. Up here, this is called the Running Man Nebula. We're back to the close-in shot of the Orion Nebula and the trapezium. You can see the 4 little stars in here that are brand new stars, and what they're doing is that they are ionizing all the gases all around it, and this is how nebulae shine. See, galaxies have stars that emit light along the continuous spectrum, but nebulae emit light by specific wavelengths of the spectrum, depending on what kind of gas it is and how much it is being energized or ionized. And without getting into too much detail here, when the atoms of the gases settle down, they emit a photon at a certain wavelength that corresponds to a certain color that we can pick up with the right filters. I find that imaging and especially processing nebulae a lot tougher than galaxies. There are more filters involved, and putting it all together takes more effort. For nebulae, I use filters that allow only a sliver of a certain wavelength through. These are called narrowband filters. And I've developed a technique where I can colorize each filtered image according to its actual emission. So all of my images are close to the real color of the object. This is a technique I've been working on for some time now. Bubbles in space. This bubble nebula is a large gas cloud that is shaped by intense winds from the big star here. Point it out to you. This star is doing all of the work here. It's in the constellation Cassiopeia. I think it looks like, I don't know, a robot or maybe the Borg. Again, this is done with my spectral mapping technique, a spectral palette of this colorizing that I've developed. Here we have a planetary nebula called the Dumbbell Nebula, or M27, as shown in the spectral palette I've developed. Planetary nebulae are lit up by a single star that has blown off its atmosphere at the end of its life. I find planetary nebulae fascinating because it's a bit of a glimpse of the fate of our own sun. Another planetary nebula, the Soap Bubble Nebula. Although this looks big and bright, it is extremely faint. So faint, it was only discovered in 2008, and it's near the Crescent Nebula. Using the high-resolution setup that I previously showed, I spent 23 nights in the summer of 2020 to capture enough data to get it to show up. In fact, I captured 70 hours of data, but threw out 25 hours because of guiding errors. I'm now getting a better guiding setup. It's very frustrating and painful to throw away that much data, but it had to be good. There are very few images of the soap bubble at this resolution, and none at this color palette, the spectral palette that I use. So what's next? My husband Peter has been working on producing a much larger telescope. This is a scaled up version of the Ceravolo 300 millimeter you saw earlier. It's a 900 millimeter or 36-inch mirror. The larger the diameter of the telescope mirror, the greater the light gathering power, and takes it all to a whole new other level, headaches included. It will be exciting when it's done. He says it's 90% finished and 90% to go. Believe it or not, it will actually fit in our 12-foot observatory. Besides doing pretty pictures with it, we will also be doing some science and running sky surveys to help track trans-Neptunian objects, comets, etc. So lots more to do. So I will leave it there, but the learning continues. Thank you for listening, and I hope I have inspired some of you to get into doing astrophotography or to take what you're already doing to new levels. This is a great hobby and has a lot to offer. It's not easy, but nothing worthwhile is ever easy. I will leave you with this 3-minute video of my best work of 2020. Thanks for watching.
That was simply amazing. Wow. And in the chat, there's comments everybody just really enjoyed, and it's been so inspiring. It's been fantastic. We're going to open up for comments and discussion, and the very first one comes from Anita. She wants to know if your cat has an astronomical name. Oh, Debra, you're still muted. Sorry.
Am I on?
There. Yeah, now we're good.
Okay, no, he doesn't have an astronomical name. He was actually first named by my husband. He was a stray. He just showed up here one day and he was very, very shy. And so he kept running away. And so Peter called him Psycho Kitty. So his name is Psycho. But I call him Kitty.
Well, if he keeps rubbing up against your tripod, Psycho works as well.
Yeah, well, he does everything with me. Even when I'm image processing, he'll sit on my lap and he'll watch everything I'm doing. He's just probably following the cursor and the changing screen, but he purrs while I'm doing it. He just loves everything I'm doing outside with the equipment. He's in the observatory with me. One night I actually even locked him in there by mistake, but he follows me everywhere.
That's fantastic. There were a few questions about the Chile images, and you said that you went to Chile, but are you also getting remote images from like SLAUSH or one of the other telescopes there?
No, we're not getting anything remote at all. Everything is from here. We're actually thinking about setting up in Chile at some point. We find that over the years, it's cloudier and cloudier and cloudier here, especially in the winter. We don't just have clouds, we live in the cloud because has such a high elevation that we basically are in the cloud for good part of the winter. So we're thinking of setting up something in Chile. That would be really great.
Well, the clarity of a lot of those horizon pictures is phenomenal, that you got such good seeing occasionally, at least.
The seeing here can be absolutely like you're in space. You know, in the summertime, because it's desert-like, it's very dry and very steady. And a lot of that depends on where the jet stream is as well. If the jet stream is over our heads and it's very turbulent, seeing is not going to be very good. But chances are it's probably from starting soon, like April until the end of October, it gets pretty good here. So
and I know the jet stream is changing now because of climate change. They're changing the models of how the jet stream functions. So that's going to probably change some of the dynamics there as well.
I think so, yeah.
Anita's asking a really good question here. One of the videos that you showed the time lapse, you showed the number of satellites and especially the Starlink train. And we know that Starlink is trying to provide communications to a lot of the rural areas further out from the urban centers. How bad is Starlink affecting your work? Does it cause you to have to drop a lot of your images simply because of trails of the satellites?
Yes, so it depends on what I'm doing. For example, the star trail photo you saw on Inukshuk, I had to drop a lot of them because it became too much effort to get rid of them. It just seemed to be that particular area at a certain time of the night. They all go through one after the other. But for deep sky imaging, they're there in almost every image. But the software can handle it at this point. I think in the future, when there are many, many, many more of them, it's going to become more saturated. It's going to saturate the detector, and it's going to become harder and harder to remove them.
Now, I saw the wonderful moon images you took, and I know most of those you didn't take with the telescope or with anything but your DSLR camera or your DSLR through a smaller refractor, it looked like. How bad do your CCDs get overexposed when you take an image like that? How long does it take you before you can image anything else because of the shadow of the amount of brightness from the moon? Or do you use filters to try to diminish that?
Well, I actually schedule my imaging events around the moon. If the moon's around, I don't not image, I just use narrowband. And then when the moon's gone, then I do the LRGB stuff that I want to get. So I have a schedule like set out for the season, basically going around the moon. And the moon is usually not a problem as long as you're willing to do narrowband.
Well, in that case, I have to ask, did you do the Messier Marathon this year?
No, it's still pretty cloudy here.
No, it's the issue. We actually managed to have a relatively clear couple of nights around the Messier Marathon for the first time in I don't know how many years. We got clearing in Montreal, but we have a curfew, so we can't actually go anywhere and do anything, which was frustrating for a lot of us. Does anybody, you're welcome to unmute and ask questions or give comments yourselves. It doesn't all have to go through me. I know David is unmuted, so I'll pass it over to David Schumann.
Unbelievably, I just can't speak. Just stunning, especially the shadow behind Neowise. That blew me away. Amazing stuff. What kind of refractor do you use?
You mean for those shots of Neowise?
No, just I saw the refractor in your that
is a stellar view.
Okay, it is. Okay.
110 millimeter stellar view. It's a nice little telescope. I sometimes have a Williams Optics, which is a little bit smaller. And Peter's a collector of telescopes, so I have many at my disposal.
I have two Coronados myself, and my friend Paul just got the Daystar, the double stack one. So we're definitely into the flares. At least in the city, it's one of the easier things to do. Really stunning work. Thank you so kindly.
You're very welcome. I'm glad you enjoyed it.
Does anybody else want to? Oh, there's a question from Jim. If you were providing any tours to your observatory during the pre-pandemic times, and if you might be going back to that after.
Yeah, we sure do. A lot of people that are visiting around call us up, and for sure they can come over. It is tricky now, of course, with the pandemic. We generally isolate here on the mountain. We're lucky that way, where we work from our home, and we're happy to be here because the views are so gorgeous and everything. So we have a very, very tiny bubble. So at the moment we don't have people coming by, but once we get the big telescope up and running, I'm sure some people are going to want to come and see that in operation.
Oh, definitely. That one looks amazing. It actually reminds me of the one we have at Montmegantic in the Research Observatory. It's a similar design of just the size of the fork compared to the optical tube.
Yeah, it's pretty impressive. He's been working on it for 6 years now with an engineer, but he's got to still finish the mirrors.
Maury, I see you're unmuted. Did you have a question?
Well, it's a question or more of a comment. I just, as a photographer who likes wide field of view photography, because I'm not a very technical person, as everybody knows in Montreal Center, but I love photography. And I really like the fact that you embrace the clouds. So many people see a cloud and they just go back to bed or go back to Netflix, but you seem to embrace it and use it to complement the landscape. And I really like that.
Well, it's true that, you can do a lot with clouds. Sometimes I find the more interesting wide field shots of the sky have clouds in them, and only some of the stars are poking through the clouds. And that always makes a really interesting photo. So.
Yeah, and as you said, it attaches us to the actual landscape or reality as we see it.
Mm-hmm.
And the Noctilucent Clouds that you mentioned, I have to admit, I'm in the same boat as you. I'd never heard of them till a couple of years ago, and now there's observations of them everywhere. There's images everywhere, especially East Coast. They've been posting images from Nova Scotia, from New Brunswick, almost, well, a couple of times a month. They've posted a few Noctilucent Clouds, and now Curiosity saw Noctilucent Clouds on Mars. It's just, they're everywhere.
I saw that comment. That's amazing. I would love to see those photos. But it is true. I was doing some research on Noctilucent Clouds, and climate change is affecting them. It's got something to do with methane in the atmosphere. It's got something to do with the very, very coldness of the edge of space. The sun's solar activity is being very, very calm right now, and it's extremely cold out there. And a lot of these things come together to make more sightings of them. And I actually saw 4 different mornings of Noctilucent Clouds last summer. Never before in my life. It's amazing.
Jim, as part of his comment about asking about tours, has been mentioning that, when he sets up his equipment at the cottage, people come by all the time. And that's one of the things I see Magellanic here, when we set up in, Dorval by the waterfront or Point Claire by the waterfront here in the Montreal area, people will immediately wander over to see what you're doing. And it makes it hard to plan out any dedicated amount of time. Whereas for you, because you actually are isolated kind of in a bubble area all the time, it's nice that way, but you're also active in the Okanagan Center, correct?
Actually, we're not that active in the Okanagan Center. We've been, since we moved to British Columbia, we've been going gangbusters with our business. And so we haven't had a whole lot of time. I was very active in the Ottawa Center. I was doing outreach. I was on the council. I was past president and teaching in the schools. I was very, very active back then.
We've had a lot of fun with the Ottawa Center just before COVID times, and even during COVID, we've co-hosted a couple of events with them, and it's always fun to get people from other centers. We've got a couple of people here from London Center and KW and out in Winnipeg, so it makes it fun to be able to connect with the centers from across the country. But now, because you have your telescope set up, do you share live feeds at times, or is it because of the internet it's hard to do, I guess?
That is a problem. The internet is a problem here. It's pretty unpredictable, but I was thinking about doing something like that. A lot of people in this past year, the pandemic, are putting stuff out there on the web. And I think astrophotography and astronomy in general has really, shot up in popularity in this past year. So yeah, I could do something like that. But like I said, unless they start bringing in fiber optics or something here, it's not so good.
I have to say, even something like what we did for today's event, where you pre-record with a few images and a few walkthroughs and then package it together and put it up, even though it's not in real time, it's incredibly fantastic. I mean, and plus then you have editorial control.
Yeah, something to consider for sure. Yeah, lots to do.
So we've managed to answer a good number of questions, but do we want to just open it up to some general discussion? Do people want to share their stories of astrophotography or of targets that they've been playing with or having time with? I know when you mentioned the number of hours you spent on the soap bubble, I immediately thought of one of our members, Ben, who did the Elephant Trunk Nebula from the middle of the city and got amazing resolution from it. So before we open up to general discussion, I see David has joined us, so I'm just going to pass it over to David before we lose connection with him again and get a chance to hear from him, and then we'll open it up to some general discussion.
Well, thank you so much, Kareem, and it's good to be back here. I'm kind of using the transporter tonight to go from meeting to meeting, from a meeting, the Warren Astronomical Society of Michigan, to the Astronomical Society of Kansas City, and now to my favorite astronomy club, the Royal Astronomical Society of Canada, Montreal Center. I wanted to add my welcome to tonight. We've had a very interesting letter from Debra, and I'm sure that we're going to have some great questions tonight about astrophotography. But I'd like to add a little bit of a poem. This poem was written by John Keats in 1819. He was just beginning to suffer from the tuberculosis, which would claim his life a couple of years later. He died, I think, at the age of 21. And so I'm going to read just the first 3 lines of the Bright Star Sonnet that he wrote. And you just imagine looking up at Sirius in the winter sky, and imagine John Keats looking up at it and saying, "Bright star, were I as steadfast as thou art, not in lone splendor hung aloft the night, and watching with eternal lids apart." And on that notice, I'd like to give it back to you, Kareem, and let's enjoy the rest of our meeting tonight. Thank you.
Thank you so much, David. And it's a pleasure as always. And so I'm going to invite everyone who wants to unmute, and we'll open it up to some discussion for about 15 minutes before we adjourn for Earth Hour. And a few of us will have clear skies during Earth Hour to take a look upwards, but the rest of us can at least enjoy a little bit of darkness and take a little bit of the light away from this incredibly light polluted Northeast where a lot of us live. Mark, how are things out in the out in the suburbs, the rural area?
Pretty cloudy, unfortunately, but look, you know, it's Canada, right? Wait another day and who knows what's going to happen, so.
Deborah, I have a question for you. I noticed that one of your photos that were taken through the Canon with your lens, I saw what looked like diffraction spikes, like from, you know, as if it was through a reflector. Was that a filter that you used over the camera, or is just an artifact from the lens? They were perfect on the brighter image.
Do you remember what photo that was?
Oh God, I don't remember. It was definitely one of the wider photos, and I was a little surprised to see the spikes coming out, considering it was a telephoto lens. I think it was earlier on in your slideshow.
There is Star Spikes Pro in Photoshop. Sometimes I do use.
Okay.
I might have used it at that time.
Okay.
I can't remember. I'd have to look at which photo it was, but.
Yeah, it was definitely one of your telephoto because you had mentioned that. But yeah, I was a little surprised to see some spikes on the brighter star.
Would it have been the one where the stars were really bloated from the frost?
No, it wasn't that one. It was something else, but it was definitely a telephoto. But yeah, okay, I didn't know, you know, if you had used like a special filter or not.
Sometimes I do, if I want to, you know, jazz it up a little bit.
Well, I'll just say one quick thing is that when I took NEOWISE this summer, as many of us know here in Montreal, we were in a remote location and it did get cloudy on one of the last nights that we could. And yet that's one of my most favorite photos where you see NEOWISE with its beautiful green, blue, part of the blue tail, and then the white dust trail going through clouds that were lit up by, you know, well, orange clouds, right, from the light pollution, but it kind of almost looked like Star Trek with nebulosity. And so in a way that's one of my more favorite photos of NEOWISE that I have because of those clouds. And I did a time lapse of it, the clouds passing over NEOWISE. So I could see that clouds can be interesting sometimes.
Yeah, so like it's really good to not give up if clouds show up, and who knows what you're going to get. It might end up being your favorite photo. Yeah.
Thanks.
One of my favorite moon videos that I've taken is of the moon passing with clouds passing over it constantly and just in and out of focus and in and out of just the detail that you can capture. It's gorgeous.
Debra, are you using anything other than Photoshop for your processing?
Is this directed to me?
Yes.
Oh, okay. Yes, I use PixInsight for most of the deep sky work. And I use Photoshop, Lightroom, and Camera Raw for DSLR images.
Great, thank you.
Hey, Deborah, it's Mark. What do you find is the most challenging part of imaging? And I'm talking from everything from image capture to processing.
Well, sometimes the most challenging thing is something that you can't control, like the seeing. I mean, basically, a really good image and a not so good image is probably due to seeing. If you're in a place, not just seeing, your sky. Sometimes people can have the exact same equipment in different places, but one person has a better sky, drier, darker. You're going to get a very different image. So sometimes I get frustrated when I'm doing my imaging in the middle of the night and it's blobby or it's trailing slightly or the RA is off, and there's always something.
Yeah.
So I find the deep sky a very big challenge to me because I only started doing the acquisition myself in the past year. Peter used to do all the acquisition because he was always testing his equipment in the field, and then he would just give me a hard drive of raw data and say, here, do something with it. And, and so I was always doing the processing and he was always doing the acquisition. But just this past year, I got into doing the acquisition, and it's not an easy thing to do. And there's a lot to learn and a lot of things can go wrong. So that, to me, it's deep sky acquisition is probably the hardest.
Yeah, there's a lot of information out there. There's a lot of videos, and a lot of them are pretty good. but I think a lot of people get the misconception that this is something that you pick up in a weekend. And it's a lot more complicated. And it really, you got to give it time. So,
Yeah, and you soon find out what's working and what's not, and you grow with it. You grow with it.
Well, thanks for your presentation. Well done.
You were mentioning that you were hoping to do some science with the new telescope more than what you're doing now. Are you looking at like the citizen science type initiatives or the variable star organization, or are you looking at actually taking on some of the research projects like the trans-Neptunian objects?
Right. Well, Peter and I are already doing that. We've been part of the Recon CanCon team where we look for TNOs, and actually the Apophis recently, we were part of the team of trying to pin down the orbit of Apophis, and we're about to embark on another expedition next week to Saskatchewan, and we're going to be setting up a couple of stations out there, because even though they have taken it off the risk list, there's still a lot of uncertainties about its orbit, in particular that the sun will affect the orbit of it because of the radiation. It heats it up on one side and it cools off on the other side, and it can actually change its orbit, and it's not perfect, and so there's a lot more to go with that. But yeah, we want to look for help with that, and also set it up for anything that moves survey, anything that moves in the north, because this is where not very many surveys are looking, is right up into the north.
Well, Kevin's joined us from rural Saskatchewan, and he's asking where you're going in Saskatchewan. I think you've got somebody interested right away.
I'm trying to think of that little town. It's between Medicine Hat and Regina. The shadow goes right through it. Maybe there's a town between the two, right in the middle. If you can, I wish I could remember the name of it. I probably have it written down here somewhere.
Maple Creek?
No.
Maple Creek.
Gull Lake?
No.
Maple Creek.
It's about 12 hours from here, so we got a 2-day drive. It's on the map. It's just a little town, but they have hotels.
Could be something like Shaunavon maybe, or Consol's too small, doesn't have a hotel, but it'll be right in that southwest corner. East End?
I thought it was Spring something. Swift Current?
There's Swift Current?
Swift Current.
Oh yeah, Swift Current is down in the, yeah, Swift Current is halfway between Medicine Hat and Moose Jaw.
Yeah, that's where we're going.
It's not a small town.
Okay.
Also notice
out in the middle of nowhere. We'll be setting up on some rural farm roads.
Jim's not too close, but next door in Winnipeg. Not too far away, comparatively.
We're also looking to get, go out on a road trip too, being cooped up here for so long.
That I think we're all itching for at this point. Especially get to some darker skies. I know we had somebody here from near Perth who's in dark skies out there. Miss them here though.
So Debra, what inspired your passion to begin with?
For astrophotography?
I guess you got into astronomy first and then to astrophotography, is that right?
Well, I think
that's usually it, but
photography, I started as a child. And my father was really into the sky, and so astronomy was a big part of my life then too. And then I studied photography after high school in college, and graphic designing. And it just kind of made sense to do the two, bring it together.
Wow. Well, so great. The images that you shared are pretty jaw-dropping as far as I'm concerned. It's I'm still quite a neophyte compared. I got a blurry image of Neowise last summer, which I'm quite proud of. But anyway, I've certainly got a great model for where I could go with this interest. So thank you.
It's a wonderful hobby. It really is. It's so rewarding.
Big time.
Hey, Deborah, I have a question for you. When you talk about the acquisition and the seeing, so when can you tell? I was always struggling with that. When can you tell if the seeing is good or not? Because there is forecast for sure, but sometimes good forecast, you really don't feel it's right. So how do you tell, like, if it's good seeing or not?
Well, basically, I just start shooting, and then I look on the computer in Maxim. I use Maxim DL, and I look at the full width half max and see where it's at before I really get going. And then sometimes it's great, and then it changes during the night. And so
yeah, because this if you look at the FWHM or the HDR, so the radius of the star, sometimes it can be because of the focusing and the temperature drop. Like
I have focusing. I had a lot of focusing issues, especially in the fall when the temperatures were varying a lot throughout the night, and I would have to refocus every half an hour. But now I've installed these InVar rods inside the tube that will focus at once, and it should just stay like that. So my whole setup, which I'm about to put together for this season, is going to be a lot better, hopefully, a lot more precise and better guiding. I got a new guider, things like that. There's just so many different elements that have to come together to make it all work. But sometimes if the seeing is not great and you think, well, should I bother? Do it anyway, because sometimes you're surprised when you put your image together. It's not as bad as you thought it was. And then you can do a little bit of deconvolution on the stars and things like that to tighten them up even more.
Yeah, exact. Yeah. All right, great. Thanks.
Deborah, speaking of gear, how do you like the Eagle?
I think the Eagle's great. It really helps in controlling all the wires. You know how you have wires like just everywhere. Well, you tie wrap them on this and that, and the computer stays with the telescope. We did have a bit of an issue with the Eagle 3 because being up here in Canada, it wasn't handling the temperatures very well, and it was doing a reboot all the time. And that's not good when you got your whole setup going and you get the sequencing happening and then it goes down. But Prima Luce was so fantastic. They actually did some testing on the Eagle 3 and they said, yeah, you know what, there is a problem with this thermal issue. And so they sent us a new Eagle 4 to replace it. And that is perfect. There's no problem at all with that. I've been running it for 3 days now in the cold and no issues there. So I really like that. And it's also very a fast processor.
Are you hardwired or are you using it wirelessly?
I'm using it from my office.
Oh, so you're using wireless. Okay.
Yeah.
Okay.
Yeah.
Thank you.
You're welcome.
A little bit warmer that way.
Yeah. Getting spoiled.
We saw the amount of the light dome of Vancouver and Seattle for you during the winter shots that you had there. Do you find that they're much of a problem in the summertime, or is it just in the winter when the light's reflecting a little bit off of the bit of snow? I guess Vancouver doesn't have much snow, so it's just the water it's reflecting off of.
No, it just is what it is. And I find that with deep sky imaging, it doesn't have any effect at all. In fact, even local lights hardly do anything. I've got a clamshell dome where I can bring up some of the shutters to deflect some lights around.
What's the Bortle in your area?
I'm sorry?
What's the Bortle index in your area?
I was trying to figure that out. I think it's somewhere between a 3 and a 4. It's not really dark, but some nights it seems dark. I mean, it depends on the transparency as well. Like I've seen the Milky Way, like I've never seen before. It's because it was very, very transparent that night. So it all depends. So like transparency is an interesting thing. I tell people it's like you got a dirty windshield and you clean it with a nice glass cleaner, and now you can see really well. That's like transparency is like somebody wiped the sky clear. And it's not always like that. I mean, it depends on the mass of the air around us.
Debra, how do you decide how long an exposure, like how do you, because for me, I thinking I'd like to have as long as exposure as possible, but where do you decide to cut it off?
Well, it depends. You really should be looking at your stars or objects and see if they're saturating.
Okay.
If they're saturating, then you're going too long and you're better off having a lot shorter exposures. Like if you want good star color, a lot of images you'll see really white stars everywhere. They've been saturated. You're going too long. So you're better off doing a lot of shorter exposures and stacking them together.
Okay, thanks.
I'm just curious, you mentioned that you and your husband have a business you started out west. Maybe you could tell us about it.
Well, it's an optical business. Sorry? Okay.
I think that was just a mistake.
Yeah, go ahead.
Okay, yeah, we have an optical business. It's primarily little tiny prisms that go into laser modules for machine vision applications all over the world, like automobile assembly, even biomedical things like we have no idea where these lenses are going, but we've been doing this for 25 years, or Peter's been running this business for like 25 years, but it used to be Ceravolo optical systems where he would be making mostly telescopes, but that didn't, it's not as lucrative as these laser optics. So that's what pays for everything is the laser optics. Meanwhile, he's still working the telescopes and he's making this prototype 900 millimeter telescope is it's like a science and research project as well for the business. And it'll be for sale if you want, you can buy it.
How much?
That I can't tell right now. I mean, it's already costing astronomical.
Forgive my ignorance, Deborah, but have you put out a book or anything like that of your astrophotography?
No.
Have you ever considered it or not?
Well, actually, Peter and I have considered doing adventures in something because we're also pilots and we fly places to do photography and astrophotography, and we thought about that. But I think my images are nice, but there are some other images out there that are just fantastic and brilliant, and so I don't know if it would be a very lucrative thing to do. Maybe just for our own.
Yeah.
Do you sell your images?
Published in books and magazines and calendars as well.
Are your images available to purchase?
No, I don't make a living at this. I don't sell them. I give them to people if they want. I could upload a link to and they can print it themselves, that sort of thing.
Okay, I have my image I'm going to send a request for.
Okay.
I love the Inukshuk when I lived in northern Quebec.
As Anita mentions.
Inukshuks mean a lot to me.
Oh, sure. Yeah, I'll do that.
As Anita mentions, the cover of the Observer's Handbook is one of Deborah's images. And she's also got a lot coming into Sky News, if I'm not mistaken.
Right.
All right, so I'll turn it over to Paul, our center president, for the final remarks.
Okay, thank you. And I want to thank Debra for amazing video there.
Very welcome.
Yes. And I'd like to, okay, and I'd like to thank David for his quote of the night, and I'd like to thank Karim for all the hard work he did to put this together, and Maury for his introduction. I'd just like to remind people that on April 24th we have another public event. A registration link will be sent out accordingly before the event. It's what's it called? It was Exciting Times in Astronomy by Dr. Anthony Moffat. What was it about? I don't remember what it was. It was topics
Uh,
about
Small
astronomy.
satellites, big stars.
Okay, because it didn't specify that in our website, so we should check that, fix that. We will fix that, I should say. And what else? Yes, and at the end of this talk, it'll be 8:30 for Montreal, but wherever you are, please turn off your lights because it is Earth Hour tonight. And with that said, I have done my part. So with that said, I bid you a good night and see you hopefully in this hopefully out in public again.
Thanks, everyone.
Thanks, everyone.
Thank you,
Deborah. Wonderful presentation. Thank you.
My pleasure.
Everyone.
Bye.
Thank you. Good night, all.
Good night.
Right.
Bye.
Happy Pesach for those that celebrate.
Good night.
Thank you so much, Debra.
You're
Yes, thank you.
welcome, Maureen.
Awesome, Deborah.
It was fun. See y'all.
Bye.
Bye-bye.
And if your travels bring you to Montreal, coffee and bagels.
Oh, that sounds good.
Oh, and smoked meat. Smoked meat, definitely.
Of course.
And it's real Montreal bagels, not whatever out west, because I was out west once. And there was a place that's in Victoria, and they sold there's a place that was selling Montreal bagels. I can tell you right now, they're not Montreal bagels.
But you know what? Peter just ordered some from Montreal and had them delivered here.
Yeah, St. D's actually vacuum packs them and sends them everywhere now.
Okay.
All right, enjoy your Earth Hour. Good night, everyone.
Good night.
Good night.
Good night.